Welcome back to Air Quality Matters and part two of a conversation with Jelle Laverge. Just coming back to you a bit, Jelle, you're probably unusual for a lot of people in your space in that you're also an attorney at law. Is that correct? So how did you end up doing what you do and also having the dark side in your life as well?
Thanks for exposing my most
Yeah.
guarded secret. No, um, well, as most things in life happen, it's pure happenstance. I maybe because of this drive that I was just talking about, trying to combine academic interests with practical things. Even as a student, I asked one of our professors for a summer job, which then led into a permanent student job, and in that office I was doing forensic engineering, which I liked a lot because it's problem solving basically, and I somehow got frustrated with the fact that I would, go to a case, do some research about what was happening, write up a nice report, send it off, and then literally 10 minutes later get a reply that said, "Thank you for these useful insights. We know what happened, but please tell us who is going to pay for all of this." I realized that I had no clue. I knew technically what was the problem, but how that related to actual decisions and actual impact in people's lives, yeah, was beyond what I was capable of. So in a mad train ride back home, I thought, well, if I want to know, I need to go study law because that's where these things are laid down. And that's what I did. And then, yeah, one thing led to another. Once I had a law degree, I thought, well, now I have it, might as well use it for something. I started teaching construction law at university because you have someone running around who knows something about technical stuff and happens to have a law degree. So let's ask that guy to give this course. And then I wanted to have real cases and to grab the attention of the students because let's all face it, engineering students. Law is not their primary focus. So to grab their attention, it's good if you can make it specific and concrete. So that's how I started practicing law, and it's really something that I enjoy because you were talking about the dark side. Well, at least it shows the dark side of the construction sector in the sense that you see where theory goes off the rails, where things go wrong, and it's really well. Some people would find it, I guess, depressing, but I find it inspiring. It shows you where there's room for improvement and how you can contribute with research, with support work for the industry.
And we often think about law in feedback loops into things like policy and regulation, but there's a critical thinking element to how you mentally work in law, isn't there? That I imagine is quite useful in the built environment and when we're trying to define standards and trying to define better ways of doing things. Because it's quite pragmatic law, isn't it? It takes balance of risk and probability and weighs things up and views things in a particular worldview. And I guess it must be fascinating to view our world through that lens.
Well, what for me really opened as a perspective in construction is the importance of roles. So as an engineer, you're taught to look at things from a technical perspective. You need to have this element connect to this element, blah blah blah. But on a real construction side, what determines outcomes is as much clarity about what is expected from whom, how you're going to evaluate things, how you're going to make sure that people are accountable for things, then that purely technical conception of the project. And that is often overlooked, especially in things like standardization and regulation, where we already talked about a lot, that it's not only necessary to define the best indoor air quality target, for example, in a regulation or a standard, but it's as much about thinking about process, responsibilities, roles on how to achieve those targets. And I've been also very lucky to work with brilliant people like Peter Wouters, for example, who recently stepped down as the long-term head of AIVC. Well, he's still the co-operating agent, but he is someone who really understands that and focuses on trying to develop quality assurance schemes, for example, like the BCCA scheme that you were talking about, keeping in mind those different roles and those actors, and what you can expect and should expect from each of them.
I suppose the other thing that law really crystallizes are the terms we often hear but don't work very well in construction often, and that is about responsibility and about accountability and about collective accountability. We hear this a lot, but it's ultimately where the gaps appear, isn't it, in the absence of those things?
Yeah, it really is. And yeah, of course, in some cases, it's really a case of people trying to skirt their responsibilities or avoid taking up some of their responsibility. But in many cases, I see it's really about just a disconnect, miscommunication about what are expectations, who is going to take some responsibility, what is the target we are working towards together. And in real life, things have consequences, and law is then there to try to figure out how to deal with the consequences. But it's much more productive to use these insights to then think before things go wrong, how you can avoid it. And for that, you need those insights about who is going to be involved, what are their incentives, what are their drives, how you can use those to work towards an interesting result or a result that people can stand by.
On one hand, construction is quite hierarchical when it actually hits site. So that this is why when we were talking earlier, you can see such a quick reaction to things like the implementation of standards. I mean, the transformation we've seen in site safety, for example, over the last decade or so is enormous. And that's principally down to the hierarchical nature on a site and how things work, that it's a solutions orientated environment. You very rarely hear politics in a site meeting. Site meetings are always about resolution and trying to work around problems. But it's an incredibly complex environment construction, because it's not just the site element. You've got professional bodies and agents and architects and engineers and commercial interest and consumers and end users, and it's a heady mix, isn't it, of interested parties.
One of the very challenging things is that traditional approaches to quality control, like GDPA circles and things like that, are very hard to implement because at least in our building market, building projects are still very much one-offs. Every project is different, and that makes it hard to incorporate experience from previous projects because you always need to rethink how it could apply in this new project. And another thing is, and I think that is something that I really see more and more happening, is that this hierarchical approach that you were talking about is fading or undermined because of market incentives again. Because more and more what we see is that contractors are more and more layers of subcontractors and people branching out work to other parties. And the more of these layers you have, the more opportunities you have for miscommunication about expectations, about responsibilities. And also the more difficult it is for people on site to actually understand what is happening, because there's 15, 20 different contractors doing their thing all at the same time, and nobody really knows who this other person is, and that is a real threat to this capability that you were talking about to
disseminate,
enforce.
and dissemination and mentorship and coaching, all of those things that we would see in that traditional structure. I've never heard anybody express that before, and I that's something I'd be really interested to understand more about, because you're right, that really could be breaking down. And if it comes with its own baggage, of course, of an industry that can be a bit conservative and slow to change because that way has always worked and so on. But equally, if we are seeing a fundamental shift in how construction is layered physically, that can affect the systems and how information is pulled and how responsibilities are overlaid, that's something I think could be very interesting to understand.
One of the more tragic examples of that is that, for example, we had a school building in Belgium that collapsed during construction, I think 3 years ago. And then if you look at what was actually going on there, and it's the same in many other construction sites, is that we talk a lot about the Uberization of the economy and the gig economy and things like that. Well, on many construction sites, individual workers are self-employed people. So if there's 20 workers on site, they could be 15 independent companies, basically, that all need to be receiving the same information, and or potential breaks in this chain of information that is necessary to make sure that the project keeps running smoothly. So I fully agree with what you were saying. It's something that needs to be looked at more if we really want to move to better quality. I think that is as much a barrier as the idea that maybe the necessary information is not available from a scientific point of view, for example.
Yeah. I mean, we've gone off on a massive tangent to the original question, which was, what are you actually up to
Sorry.
in Ghent? But no, I mean, it's a fascinating one at that, and one of the clear demonstrations of how that maybe is going is the fact that this push for modern methods of construction and off-site construction is really struggling at the moment, because that's based on a principle of manufacturing and ISO and quality processes and consistency and those kind of hierarchies. But we've had a number of very high level failures of those types of organizations because they haven't been able to create the business model that works. That it appears, and I'm no expert in it, but it would appear on the surface that construction is very much propped up by the fact that you've got these disparate organizations that can just be laid off or can just be not paid if you run into financial trouble. That it's quite a broken system. And when you try and apply that to something with the rigor of off-site construction and manufacturing at a grand scale, it doesn't seem to work for some reason. There seems to be, I don't know if that's the same across Europe, but certainly in the UK, we've seen some very high profile failures of off-site construction and manufacturing. And it appears to be principally because the supply is so varied that the demand, it goes up and down so much that a factory has to supply at a consistent level in order to maintain the quality and the skills and the processes, and it just doesn't seem to be meshing for some reason.
Yeah,
you know
that plus that, of course, the construction industry, while it is a very big sector in most economies, is also typically a sector that is operating at very low margins, or at least big chunks of it are operating at very low margins, while manufacturing and the factorization process that you were talking about typically requires high throughput and high margins to be able to maintain all of these additional quality steps. So yeah, it's a challenging environment to work in.
We digress massively, but to elegantly bring it back to ventilation and air quality, one of the comments I made recently was that it was very difficult to have a lot of policies and procedures and care into outcomes of ventilation and air quality when you're selling a 40 quid bathroom fan over a trade counter. That those kind of low margins don't often lend themselves to quality of outcome. And we give manufacturers a hard time sometimes that they don't care too much about the end result once the box is sold. But it's very difficult to care much when there isn't a margin in what you're selling. And that's one of the challenges when you're trying to engage with the supply chain for better outcomes, is in that tight kind of sector, it's very difficult to have those kind of policies and quality controls to get good outcomes. So back onto the question, what is it you do in Ghent again? So you're an associate professor in Ghent. In what department? What's the kind of stuff you're working on at the moment, and what are you teaching?
Yeah, so we already established that I'm a lawyer, and therefore I teach construction law. I'm an associate professor in the Department of Architecture and Urban Planning. So we run a program in architectural engineering, or well, there's another good translation into the UK framework, but I guess you could call it a combined degree between architecture, so design, and engineering. And so we are the Department of Architecture and Urban Planning within the School of Engineering, which is a quite unusual setting if you look at other universities or settings in other countries.
Does that produce an unusual quality of students as a result, being within engineering and architecture? Is there a result from that unusualness?
So the type of professional that we're trying to create there is someone that can actually be kind of a central person within a building process, in a sense that they can do the design part. So they are able to understand very clearly and to discuss what architects are trying to achieve with a building. So in terms of spatial dimensions and architectural quality. And they are able to then take those ambitions and translate them into the challenges for the technical team, the civil engineering, the architectural engineering, the mechanical engineering, and also talk with them in their language to make sure that these ambitions match and lead to a realization that actually makes all of these things come true. So that's, by the way, also the program that I followed in undergrad studies. And it's challenging in a sense that it tries to tackle very different ways of knowledge gathering. Thinking in a design perspective is somehow very different than pure engineering is somehow different from understanding contextual information about meaning of buildings, art history, aesthetics. But I would not trade it for anything else. It's for me what working in the building sector is all about, and I'm very proud to be in that program and hope to be for the rest of my career.
So apart from the teaching and the law, you're also involved in a continuous stream of research projects.
Yeah, and there I mainly focus on, or if there's a red thread between it, it's performance based design of HVAC solutions, mainly residential ventilation, but also non-residential ventilation, or heating and cooling. We had a really big project on hybrid geotaps, so that's radiant-based heating in non-residential buildings, but also focusing on how can we improve the design by focusing on the performance during the design process.
And you also take the lead on Annex 86. Is that right?
Yep.
Explain to people. I did get, I think it was Max, to explain what the International Energy Agency Annex 5 AIVC was all about, and how annexes work under the International Energy Agency. So I'd encourage those that haven't heard Max to go back and listen to that, because I think it's a good explanation of how this all works with various involved countries. And
it's certainly not the only reason to go back and listen to that episode, because I thought it was fascinating.
I always enjoy just listening to his take on things. He has a great way of explaining stuff. And one of those annexes, we're now up to. Are we up to the hundreds yet with the annexes? Yours was Annex 86.
We're 86, and they're now in the 90s, very much approaching the 100. Yeah.
So typically, annexes are 3 to 4 year programs where countries come together and look at a particular topic. And Annex 86 looks at energy efficient air quality management in residential buildings.
So the important thing to remember is that IEA-EBC annexes always try to work on challenges that address the energy question. How we can improve scientific understanding and policy making around transitioning our energy system. And so, for all of the reasons that we discussed before, residential is a big part of our building stock. Buildings take up a lot of energy in their in running them. And indoor air quality is a big constraint if you want to think about how to optimize energy use in buildings. So that's the general idea about why doing an annex about indoor air quality management. It's not the first one. AIVC was created as Annex 5 to, provide a platform for working on that. There's been many annexes working on ventilation and indoor air quality related to energy use. One, or probably the last one in that row, was Annex 68, where we worked on combining insights on humidity, air transport, and pollutant transport into a coherent view on the performance of a dwelling, trying to put forward criteria and things like that. And then Annex 86 really continues that, but looking at, or it's really deliberate that the title says indoor air quality management and not ventilation, for example, because we believe that, as you said, that there's different levers that you can pull on. And what we found was lacking is that there is an overarching framework that allows you to weigh which lever to pull on, how to make choices in setting up a strategy to improve indoor air quality, and that is the global ambition of that annex, and we have different subgroups and subsections that address individual parts of that challenge.
So there are principally 4 or 5 subgroups, and actually Ben Jones, who we had on a few weeks back, a lot of the work that he's doing in Nottingham and Max is doing in Lawrence Berkeley around harm and harm intensities of indoor air quality is one of those parts of the subtasks. So it's really generating some meaningful work and a vehicle to focus in on some specific areas. But I guess the principle of this is to develop a framework, metrics, and a strategy and a rating method, so that you can make decisions in a space about is it source control, what is the harm that something's, what is the goal, what does good look like in this type of space.
And so on deciding on what to work on in that annex, this is really what we had in mind. When I present it, I often call it a rating ecology. It's trying to put in place all of the different bits and components that you need to have available to make those decisions. So, for example, you mentioned the work of Ben, where he really focuses on developing additional metrics, meaningful metrics, on how to weigh exposure of different pollutants against each other. And if you try to reduce the exposure to one, you may increase the exposure to the other. So how should you work on that? So that's mainly subtask 1. Then we have another group, subtask 2, that tries to put in place the input that you need to make those design decisions. So, for example, collecting available information on source strengths in buildings or typical exposure profiles in buildings, so that you can pull from that to create a realistic scenario for your design, to then base or explore the effect of different decisions on those parameters.
And that's an incredibly important element of the work, although it appears quite theoretical. I mean, Ben was describing it quite eloquently, I think, when he was talking about some of his work he was doing a few years back on trying to understand the characterizing the pollutants generated from cooking. If you don't have that data, or that data isn't well formed, it's very difficult to input something into a model, say, that's going to be useful. So source characterization and developing robust exposure methodologies is really important, isn't it, when you're trying to develop some of these frameworks?
Absolutely. So it's also, yeah, you were saying when you were introducing the topic, like, okay, you're putting in place modeling and things like that. Actually, what we thought is that we have the modeling capability available, so that we have relatively advanced models to look at the dynamics of exposure in buildings and airflows and things like that. But what we're really lacking is the precise and high resolution and high quality input information for those models to use them in a typical design context. So yeah, that is really at the moment still a big bottleneck in trying to apply these performance-based approaches in practice.
And then in typical fashion, to bookend the process, one of the subtasks looks at the performance of ventilation systems as well. So understanding how when we understand what we want to deliver, how do we actually ensure that we get that? There's a couple of questions I have around that. I mean, it talks about smart ventilation. We've seen that concept developed over the years, particularly through the IEA and some of the subtasks. There is a definition for smart ventilation, but what is it in your eyes when we describe smart ventilation? What is that supposed to be delivering?
Yeah, so there is indeed a quite long definition that was worked on by many people within AIVC and is available on the website. And that's also, by the way, the definition that we're using within the annex as a starting point within the group that is working on smart ventilation. But to try to summarize it in a few sentences for me, and I will not do what Ben did when he was on the show, like pulling out of his head the verbatim definitions. But it really comes down to having a ventilation system that is able to match the supply of IAQ management, IEA ventilation, if we're dealing with smart ventilation, to the need and provide additional services related to that. So that, yeah, that is where we're starting from, systems that are autonomous in a way that they are able to match the quality of the service to the demand. And so in Belgium, for example, we typically speak about demand controlled ventilation, which is one type of smart ventilation. But it could also be, systems that provide services that allow you to follow up your exposure through an app. So give you additional information, inform you, trigger responses, things like that.
Yeah, and that's why it becomes even more critical that we're then framing what the boundary conditions of what good looks like. That's part of the annex, is
exactly
to develop that framework so that we can expand what demand control ventilation or smart ventilation really means, because we increasingly ventilation is tied into energy systems, and it may well be it's reacting to grid capacity or carbon emissions of something or behavior change. I mean, it could be smart, can mean many things. So we have to create some frameworks around what a good outcome looks like. And to do that, you need to understand source characterization and typical exposures and so on. One of the interesting subgroups within that annex is smart materials. And it seems like an odd addition, but actually when you listen to some of the work that they're doing, you realize it's incredibly relevant and actually quite an exciting frontier at the moment of science and product development, isn't it?
Yeah, so they're operating at what you would call a different TRL level, so technology readiness level. They're much more into still, material development and early research and trying to upscale this into really usable, practical products. But the reason and this is something that I tried to defend quite strongly when we were setting up the annex. The reason why I think it's necessary that they are there is that they push us to think beyond the levers that we already know. If we're setting up this framework, it should be in such a way that it allows other options of improving indoor air quality. For example, by adding air cleaning, but that's dealt with in a separate annex. But for example, also by thinking about what all of the surfaces in our spaces can deliver in terms of services by absorbing pollutants, by providing catalytic reactions and things like that, in our overall ambition to better manage the indoor air quality in the space. So it's again another lever that we are trying to make available, and we have it in the annex to make sure that we take into account the fact that there's probably even other levers that we're not thinking about at the moment that also will need to be able to be inserted in our thinking about rating indoor air quality and getting towards that performance that we're looking for.
And I often operate outside of my depth in many areas, but I have to say, having sat into a couple of the discussions on smart materials, you're talking about some pretty advanced chemistry going on in that sector. And I get by when I'm understanding about 75% of what people are saying in engineering terms or kind of building physics terms, but the kind of chemistry that those folks are talking about, that's another level, man. And I've seen some fairly bright engineers switch off in some of those conversations as well. You can tell it's very specific. That
It is,
one,
but
yeah.
then if you are able to zoom out a bit and see what kind of applications they're actually working on, for example, having a fully reversible, very high capacity zinc material that is able to absorb formaldehyde in your space that can easily be regenerated afterwards. And you combine that with the insights from, for example, Ben's work, where formaldehyde is one of the key pollutants that contributes to harm in terms of health outcomes. That allows you to really rethink how you should design your indoor air quality management in a space. Because if you can target the most harmful pollutants, you can deal with harm in a certain way, and then you can focus on other things like, for example, perceived air quality. All of a sudden becomes again the big thing to think about. Now, is this air quality actually still acceptable for people in terms of perception? And then you can use air cleaners to that, and in certain conditions it makes sense to combine all of these strategies to achieve better outcomes.
And then the final subtask, the final one is the dissemination piece, which I guess comes much more towards the end of the annex, which I believe, if I'm correct, will be autumn next year.
Correct.
But one of the other subtasks then is improvements and validation through cloud data and IoT connected devices, which is a subject matter, as you know, is quite close to my heart. And I think that's a fascinating part of the whole smart building, smart ventilation, energy saving picture, is this proliferation of data we're seeing, both from an energy perspective, but also from an environmental perspective. So it'll be interesting to see how that slots in with the ground thinking.
Well, that's a part where we've been blessed with your involvement also, so that that's where we really need the type of profile of people like yourself who really have a good connection towards industry and companies that are, because this is something that we really need to face from an academic or research point of view, is that big data also means that some players are amassing huge amounts of data, what they not always know exactly what to do with. But on the other hand, they are taking decisions that impact which data is available, how it can be used, and how it can be implemented in all of the devices around us. So it's a very fast moving sector, and now it's me who is talking out of his depth, because you have much more practical experience with it. But I think it's something that we need to be acutely aware of and trying to engage with, to make sure that we're not sidelined as people who are trying to grasp with all of the engineering of how to design indoor air quality, but by reality that is just passing us by, basically.
Yeah, there's these parallel tracks at the moment, from what I can see out there, where there's huge hunger academically to understand the performance of spaces. That's typically been very difficult to do and expensive. But at the same time, we're building these business cases for data that are enabling them to be deployed purely on a business case. So whether that's in the workplace, helping with automation and retention of staff and absenteeism, or operational efficiency of the space, whatever the cause is that creates a legitimate business case for the deployment of those sensors. Increasingly into the residential sector, there probably isn't a heat pump or a smart thermostat that's going into a space that isn't recording some amount of environmental data now at this stage. So it's coming from all sorts of quarters, including very devices and businesses specifically set up to deliver value into the residential space, now albeit predominantly into the rented sector, where you're trying to help those organizations responsible for those buildings manage them better, so spot voids or fuel poverty or condensation risk or something like that. But those business cases are being made all over the place, and including from your own country. One of the manufacturers there of ventilation systems, Renson, that they already have an enormous amount of data on the performance of their ventilation systems out there in the real world, beaming up data to a cloud as we speak right now. Right down to when the bathroom boosted last, or what percentage of the whole house rate that ventilation system is currently working at, and why, and what decision it made in order to do that. It's coming. It's not all just edge data now, edge analytics that are used to make local decisions. Those decisions are being looked at in a central place and feeding back information. So it's
and it's that feedback loop that really creates new opportunities. Working with the data you were just describing, one of the key takeaways for me was that being aware of variability in how what happens in houses and how they are operated, and making sure that if we are working in standardization or working on design guidelines and things like that, providing tools, they need to be capable to absorb all of that variability and take it into account when you're making design, making advice to people on how to improve their indoor air quality, because there really isn't a one size fits all solution.
No.
And that level of customization is probably much bigger than we always anticipated.
And I think probably one of the big next steps that the supply chain as a whole, and I include all the way from design through to the manufacturers and installers of these systems, have to try and get their head around, is that it's changing the kind of questions that you're getting asked. You are being judged increasingly by the ongoing performance of the systems that you design and install, and much less on whether that system happens to meet a standard or regulation on the day that you switched it on in someone's home. Which means at the moment that's uncomfortable. Companies are being asked questions they don't know how to answer. They don't have the terminology and the competency and the experience internally to answer those questions. But they're going to have to develop that over time. But I'm quite convinced within the decade there's not going to be many spaces we occupy inside that there won't be some form of environmental monitoring in. And that changes the dynamic.
Chances are big that it's going to be just in our phones. Basically, it's something that we've been having fantasies about for maybe 10 years, but I think it's going to happen, and that change, ventilation as a performance or as a service has been put forward by people, really visionary people, trying to imagine how you can transform this industry. But we are at the point where we have, I think, the technical capability to actually implement it. And we need to make sure that our regulatory framework and also our legal framework, by the way, is able to accommodate all of these things. Because as you were saying, people trying to actually do that are still facing many questions on, okay, what is then the responsibility that I take on? How can I make sure that I can separate things that I'm responsible for from things that the occupants, for example, need to take responsibility for? What is it actually that I am providing if I'm thinking about ventilation as a service? Is it the flow rate? Is it an indoor air quality? How to deal with uncertainty?
It's brilliant.
So
lens.
these are all...
It's a brilliant lens. As a service, models are nearly always born out of products and technologies getting to the point where you can frame the performance of that particular service effectively. And it's historically been in the realm of very high cost products. There's famous as a service models for Apache helicopters or jet engines and things like that, where there's the value in the product that enables you to invest huge amounts of money in sensors and monitoring and supply chain programs to deliver airtime of that helicopter or that jet engine, whatever it is. But also it casts a lens on the use of those products as well. So you start to develop very deep relationships with the users of those products to get the most out of the product. Who's flying that aeroplanes sympathetically, and how do you train and educate and frame things to the users of those products in a way that makes the business model stack up. The beauty of an as a service model is there isn't a part of that model that you don't have to be on top of if you're going to be profitable. So it really casts a systems thinking, critical thinking lens over something that doesn't necessarily have it. And where we are with ventilation now is that we're getting to a point with the cost of sensors where it's doable on ventilation. The only concern I have, and it's just really a kind of the devil on my shoulder whispering in my ear, is there's something a little bit distasteful about selling air. So the air quality as a service model, I just let the instant images of business selling air and what happens when you can't afford it kind of scenarios.
Yeah, but there's also another one that I think is really important, is that the goal of having an indoor environment available to you in many cases is also to provide you agency to do things that you decide yourself. And so the cases that you were talking about, there it's very clear that you can target a wanted behavior in terms of maximizing performance. And that's much less clear if you're dealing with situations where actually you want to give people the ability to explore the things that they want to explore, and just assist them with good indoor air quality along the way. So the traditional or more simple ways of thinking about performance of, okay, this is a target pollution level, and 99% of the time it needs to be below that, is probably not a useful way of using this air quality or ventilation as a service model in essentially residential buildings or other buildings like a school. You don't want to limit the things that teachers can how they can engage with their students, because the prescribed use of this space is that the level of CO2 always needs to stay below 1,000 ppm, and so if there's an extra person coming in the space to talk about something exciting for the students, sorry, this is not possible. So it's it's a much more complex context where you're trying to provide that service, and it's more about, in my opinion, accompanying people in a useful way, and still trying to articulate what the added value is that you generate while doing so.
I think it's analogous to a lot of the complex conversations we're having in the built environment now about many subjects like this, whether it's circularity or what sustainability actually means, or whether it's the environments that we occupy and the trade-offs of choices and risks that we face. I don't think that obfuscates us from having those conversations and trying to deal with it. But it certainly makes it more complex than just saying, well, you're doing 10 litres a second per person, you're fine, job done. Mm-hmm. It puts a magnifying glass on the whole system when you start looking at as a service models, and businesses are very reluctant to go down that route because of the inherent liability that it carries. But it is happening. I'm aware of boiler manufacturers, for example, at the larger end, where there's the value in the product, where they're starting to look at a couple of different layers of as a service models for delivery of heat. And heat's relatively simple to measure. thermal comfort isn't, of course. But air quality is another level of complexity, I think, and that's going to be the challenge. And I think perhaps why work like Annex 86 is going to be so important, because without those frameworks, it's very difficult to move to that state.
Yeah, it's from that observation that we try to do this work, and then we hope to be able to continue it. Well, the annex, of course, is, as you say, ending in October. But we have many exciting new initiatives on the horizon, and certainly a great group of people in this field that are trying to push exactly those things that you were pointing at.
Yeah, thanks so much for your time this afternoon. It's been
Yeah,
brilliant to
I
talk
hope
to you
you
as
liked
always.
it.
Yeah, really, really good. And if it's okay, we'll have you back on at some point to catch up on some of the really interesting projects you're working on.
I would be very glad. Thanks.
Thanks a million.